Howdy, howdy. This is Mr. Potter. In our last video, we talked about how the 11 board would actually be played out. We talked about how to check to see if a pair of cards added up to 11, or if we had 3 cards that contained a Jack, Queen, King. But we also talked about how we could use those same methods as long as we were using a list of any size to check to see if a particular play is legal. So we have this: if selected cards dot size is equal to 2 and contains a pair, and we have this: if selected card size is 3 and contains a Jack, Queen, King, then we're going to go ahead and return true. What we're going to today is I want to talk a little bit about abstractness. Now, we dealt with abstract classes before. The idea is that we want to write some generic class which has most of the pieces in it, and that we just fill in the pieces later. So what I've got is I've got this board class. This is the board class in the Activity 9 folder, and it's an abstract class. The fact that it's an abstract class means that there are some methods that aren't written here, and that anything that extends board should have overwritten. So I want to go through this, and I want to draw the similarities to what we've already done with our ElevensBoard, with this board here. So the thing I want to note down here at the bottom, these are our abstract methods: the is legal and another play is possible. These methods, the fact that a play is legal is actually determined by the rules of the game. It's not determined just because it's an 11s game. The idea is that I can use this board for another game if I can establish some rules and write methods that represent those rules. I could have other legal plays. And so I just need some method that has an array list of cards called selected cards that will return a boolean. But notice this method header ends in a semicolon, and the method is listed as an abstract method, which means the code here is not going to run. I'm not going to be able to create an instance of a board class using new board. I'm going to have to have a class that extends board. And similarly, I've got this public abstract boolean another play is possible, because the same idea that several methods would determine if a given play is legal. I'm also going to have several methods that determine if another play is possible. So I'm going to have to overwrite both of these methods in my 11s board class. So this is the 11 board that we did in an earlier video, in our last video. This is our generic board class. So it's an abstract class called board. We still have an array of cards. These are the positions of the cards on the board. We still have a deck of cards. We still have a Boolean I am debugging. This constructor is exactly the same. We're going to create a new array of cards, which is our playing surface. We're going to create a new deck with the given ranks, suits, and point values. But notice that those are missing here. Because if I'm playing a game like blackjack, the point values are going to be much different. The ace could be either a 1 or an 11, and the jack, queen, and king are all going to have a point value of 10. If I was playing spades, or if I was playing hearts, then I'm going to have to keep track of the points based on the rank of the cards. So a jack would be an 11, a 12 would be for a queen, a king would be a 13, and since ace is high, then I'm going to want that ace to be a 14. So because the rules of the game determine that, we're not explicitly listing those. So those are things that we're going to have to implement. For whatever class extends ElevensBoard, which that's actually what I've got here, and we'll talk about that in just a few minutes. But the fact is that we're still dealing with cards, we're still dealing with decks, and these are classes that we wrote way back in Activity 2. We still have to know the size, how many cards we have in our surface. We still have an is empty to see if all of the cards are empty. That's kind of necessary for our game winning state. We still need to deal at a particular location. We still need to know what the deck size is. We need to know what card is at that particular spot. We'll need to replace cards at a given list, which is part of actually making that successful play. I mean, we have this idea that we can make we can see if a play is valid, if the play is a good play, if the play exists, but we still need to be able to make that play, to actually remove the old cards and replace them with new cards. We've got this method called card indexes, which allows us to get all of the cards for a particular list, everything that's not null. And we didn't use this. We actually wrote a method very similar to it when we did our ElevensBoard last time. We got a two string. We've got whether or not the game is won. Basically, the game is won if there's no cards in our deck and there's no cards on our playing surface. That determines whether or not we've won. So we've got this is legal, and we've got this another play is possible. But notice that I don't have the other methods that we were talking about. Most notably, at the bottom of our ElevensBoard, board, we had our contains pair sum 11 and our contains Jack, Queen, King. And we can literally copy these methods from our 11's board. Let me go ahead and copy these from our 11's board that we wrote in our last video. Paste them down at the bottom because these are the only two valid plays that this particular game has. But wait a minute, this is the board class. The board doesn't care about the 11. So I really don't want to paste them here. I want to make sure that they're in this 11's board, which is going to extend it. So I'm going to scroll up to the top and take a look at this 11's board. Keep in mind this extends board, so it gets all the stuff that board has. We set our board size at 9. If you've ever played the traditional solitaire, the board size is 7. And there are other versions that would have a larger board as well. If you've ever played there's lots of different versions of solitaire that have different board sizes. We've got our ranks, our suits, and our point values. And notice because matching Jack, Queens, and Kings is an idea that we want to have as a successful play, we have those point values being 0 respectively for those ranks. So our 11's board constructor basically calls on super with the board size, the ranks, the suits, and the point value. Notice that our constructor for board actually has the size as a parameter that's passed to it. It's not a instance variable. It's not a static final in our board class. It actually ends up being a static final in our 11's board, which extends it. So we have our is legal, but if I want to know if a particular thing is legal, these are the steps that we had in our 11's board. We have our is legal, we have our another play is possible, we have contains pair sum to 11, and contains Jack, Queen, King. We wrote all of these methods before, and so it's going to be very easy for us just to copy the existing methods here. So these methods we're going to copy, and we have to copy it because the board has no notion of the Jack, Queen, King, or the contains pair sum 11. So we went ahead and copied and pasted those. And then we have our board.java needs to have the following methods written because it is an abstract class. We need to have is legal, and we need to have another play as possible. These are abstract methods that we need to fulfill. So we're going to go ahead and open up our 11's board and copy the code for these. So we're going to have our public Boolean in another place as possible, and our public Boolean is legal. And so what's nice about this is that, I mean, it looks like I'm just reinventing the wheel here. But in actuality, what's happening is we have this board.java, which we can compile and works fine. And this ElevensBoard, which extends board. So we call on all the extends method. Ooh, something's really bad here. Let's take a look at what this is. I probably have a braces out of place. Elevens goes backdoor enum expected. That's on line 103. So if I scroll to 103, oh yeah, I have too many braces here. Silly me. It's the issue when you copy paste is that you have to be careful of these things. Cards has private access in board, so the thing is, I'm not going to be able to access cards.length because cards is private in board, which means only board can access cards. I'm going to have to use the accessor methods that board has. Keep in mind that board had this int size, which was a public method. So instead of using cards.length in this, I actually want to just use size. And that's going to take care of that issue. And of course, we're going to have some other errors here. If card sub by is equal to null, I'm going to have to find some way to get the card on line 80, because I want to know if this is equal to null. And actually, keep in mind that this whole idea of this working, we really need to go ahead and use the method we had written in our board class. So we need to go up to this method of card indexes. So we're going to go ahead and call on card indexes, which is going to give us the list we want. And instead of saying list integer selected cards equals new array list, we can actually just say this is equal to list indexes. Indexes. Did I spell that correctly? Card indexes. Card index, not list index. So now, if we compile that, that should take care of that issue. Card still has private access here, so C1 is equal to cards.selected cards.get I. So there should be some way of accessing the card at a particular spot, and there's the card at method. So for this line 105, we want to go ahead and get, this is going to be card at. So this is going to be card at I. And similarly, we're going to have to do the same thing down here and say C2 is equal to card at J. And so this is how we get around the fact that cards is a private array in our boards class, because board has accessors written for all the stuff that we need. So let's compile that one last time. Does that take care of all of our errors? There's one more error. And of course, that's the issue we had here. Card C is going to get card sub I. I really want to do card at I. So that should take care of that for us. And so if we run that, then that compiles. Now, I'm still not in a position to run this, but what I want to do is I want to talk about a slightly different game. So I'm going to load a different game in our activity 9, actually in our activity 11 folder. And this game is the 13's board. So 13's is a game that's very similar to 11's. The idea is that we want to pick up cards that sum to 13. So in this case, I would do a 7 and a 6, or I would do a 5 or an 8. 4 would go with the 9. 3 would go with the 10. A 2 would go with the jack. And so notice that the 2 and the jack have point values of 11. The 1 and the queen, which has a point value of 12, would add up to 13. And anytime I see a king, I could just pick it up. So this is a very similar idea behind it, but instead of looking for a jack, queen, king combo, the kings are the only things that we can pick up by themselves. The jack and the queen are 11 and 12 respectively. Now, the constructor for this runs the same way. So I've still got the board size, the ranks, the suits, and the point values. But here we have our point value of 10. Because we're actually looking for more pairs, this is actually a more difficult game. And so the board size being 10 means that we have to kind of compensate for that. It's a more difficult game, so we're going to add more spots on the board. Our ranks are going to be exactly the same. Our suits are going to be the same because we're still dealing with the same cards. What's different is the point values. And the main difference down here is the fact that Jack and Queen have point values that aren't 0 as they were in the ElevensBoard. Now, it is legal. We're going to have some code here. So we've got if selected card size is equal to 1, then we return contains king. If selected size is equal to 2, then we want to contain pair sum 13. So we've got these methods that we're going to have to tweak here. So I want to know if another play is possible. So I've got this list array of integers that gets the card indexes, and I want to know if it contains some pair of 13s or contains a king. And then we need to talk about what these are doing here. So notice what we've got here. If it contains some pair of 13, this is very, very similar to what we had been doing before. So we go through the list of cards that we have, and we see if the card at that value plus the card at the other value add up to 13, then return true, otherwise return false. This works for selecting just 2 cards to see if it's a pair, or if I have all the cards, as we had up here with this another play is possible. We're looking at all of our cards using the card indexes method. Then as long as some pair adds up to 13, we're just going to say, yeah, there's another play to be had there. And similarly, if we can contain a king, all we're doing is we're checking to see if the rank at a particular spot is equal to king. So we can see if the one card was selected, if this is the player selection, or we can see if multiple cards, multiple kings exist throughout all of our cards. So what we have here is we've got some other methods that we're going to have to write in order to implement the play of the game. We're going to do this for our 13s board, and we're going to do this for our 11s board. But we're going to do this next time, because next time I want to take an in-detail look at how the GUI is developed. Because we've run this program, we know that there's a graphical user interface. And I really would like to see how the GUI works. So, once again, this is Mr. Potter. Thank you for watching. Have a great day.